Hi everyone, welcome back. Layer 4 is transport layer and it is responsible for providing reliable data transfer service between devices on a network. It ensures that data is delivered error-free, in sequence and with no losses or duplications. Provides end-to-end communication services for applications, segmentations and reassembly of data. Segmentation is again this kind of fragmentation. First to create the fragment of a packet, and then at the destination side reassemble those fragments to have the packet again. Error detection and correction and flow control. Example include TCP, transmission control protocol, and UDP, user datagram protocol. Please let me know if you want to know more about TCP or UDP. I will create another video. Okay, so functions, what it provides. Segmentation and reassembly, like I said, divides the data received from the upper layers into smaller segments to be transmitted over the network. Each segment is given a sequence number which allows the receiving transport layer to reassemble the data correctly. For instance, if you download a file, the transport layer on the center side will segment the file into manageable pieces, and the transport layer on your side will reassemble them into the complete file. So understand one thing, this whole layer, the 7 layers, right? It's there on sender side as well as receiver side. Don't get confused, because when I'm saying the transport layer on the center side will segment the file into manageable pieces, while sending I will first divide it, and the transport layer on your side means the receiver side will reassemble them into the complete file. Okay, flow control. This layer manages the rate of data transmission between devices to prevent overwhelming the receiving device. Flow control mechanism like TCP sliding window ensure that data is sent at a rate that the receiver can handle. It should not be that I'm just bombarding the information and then the receiver cannot even have that bandwidth, cannot even understand. So for example, a badminton, if I'm too fast and I'm just hitting the ball again and again, and the receiver, the other person, right, who is competing me, maybe just a new guy, doesn't even understand how to hold the bat, etc., so cannot take those fast forwarding balls, right? So I'm not a good tennis player, but just to give you an example. For example, and for this example is, if the sender is faster than the receiver, the transport layer adjusts the transmission rate to avoid packet loss and congestion. Error detection and correction. The transport layer ensures data integrity by detecting errors in transmitted segments. If errors are detected, it can request retransmission of the affected segments. This is crucial for maintaining data accuracy during communication. Protocols like TCP uses checksums and acknowledgements to ensure that the data received is the same as the data sent. Connection establishment and termination. In protocols like TCP, the transport layer is responsible for establishing a connection between the sender and receiver before data transmission starts. This is known as a three-way handshake. After data transfer is complete, the transport layer also handles the proper termination of the connection. So it is like before that, even that transfer is happening, they make the connection, and then once the connection is established, the transfer happens, and after that the connection is terminated again. Multiplexing and demultiplexing. The transport layer allows multiple applications to use the networking simultaneously. It assigns different ports to different applications, ensuring that data intended for a particular application is delivered to the correct process. For example, your web browser might be using port 80 for HTTP, while your email client uses port 25 for SMTP. The transport layer manages this process so that the correct data goes to the correct application. Protocols at the transport layer. Like I said, TCP and UDP. TCP is for transmission control protocol. provides reliable connection-oriented data transfer. It is widely used for applications like web browsing, where we use the HTTP or HTTPS based on if it is secured or not, email SMTP, and file transfer FTP. UDP, User Datagram Protocol, provides connectionless, unreliable data transfer. It is used for applications that require speed and efficiency, such as video streaming, online gaming, and DNS lookup. Web browsing. When you browse a website, the data your browser request is transmitted over TCP, ensuring that the web pages are received correctly and in order. Streaming. When you watch a video online, the data is often sent using UDP, which allows for faster transmission but may result in occasional data loss. And that's it in this video. Thank you so much for watching.